particularly fond of. Some people view as a non-solution for some people. So it's a solution for some people, but not others. And there are multiple ways of solving this problem. In this case, the solutions are not one size fits all. And I'm going to describe several of them to you. So one way to deal with that problem is to not deal with keys at all, to deal with passwords. So this is a solution that Nadim Kobayashi, I don't want to mess up his last name, but Nadim he's the guy behind CryptoCat and Minilock, and most recently Pure.io. And he's with Minilock and Pure.io. In Pure.io, he's using the same technique he did with Minilock. What he does is he does his best to force users to pick a very strong password, like long and memorable, but long, and hopefully secure from brute force attacks. And I believe in Pure.io he uses script on top of that, so that's another thing to stop brute force attack, well, to mitigate against brute force attacks. And then using that password, he generates, based off of that, deterministically a public-private key pair. So if you just got a password in your head, you can't lose it unless you forget it. And you can back up a password on multiple devices if you have a password manager or something along those lines. So in that case, it doesn't matter if you lose your private key, because you can always rederive it from your password. Another solution is what's called, some of you are probably familiar with the concept of multisig. Show of hands. How many of you are familiar with multisig? Okay, about like 80% of you. And so multisig allows you to not to distribute to reduce the number of failure points. So you could lose your computer and your key, but if you've got a couple of friends who are using some software that stores part of your private key, then you can still recombine the actual private key eventually. Yeah. And a similar technique is called Shamir secret sharing, which is a very similar technique to multisig. I think it works, but I think it works differently. And that allows you to do, again, n of m shards. So you can take your private key and you can choose, say a dozen people to distribute shards to, and then you can choose the number of people that have to get together to recombine the secret. And then there are of course backups. People do that, I don't know. And then there's this other thing where you have, the best way I think to do this is, and the way that we're suggesting doing it with a project called Blockchain ID, is to, oh, I forgot another one, keys, like physical hardware devices, secure hardware devices that actually have the private key. So, I mean, some people like those. I'm not a big fan of them because it's just like another gadget that I have to deal with, but you can do that. At some point in the future, there will probably be biometric, where maybe scanning your iris or something like that, your private key key pair will be derived from that. There's lots and lots and lots of solutions that can be used, and there's probably one solution for somebody out there that works. So in the end, and the solutions, notice they involve different levels of user interaction with keys. I prefer the solutions that require no interaction with public-private key pairs for users. And passwords are something that users are very familiar with. Strong passwords, not so much, but yeah. So there's some kind of solution to address that.
Well, so the thing is, I use LastPass. It's been a pain in the ass trying to get my wife to use it. She just doesn't even want to use it, right? And so many other people that you talk to. So mass adoption of this sort of, new usability or new user experience. I mean, does it come at a point where someone like Google adopts it and says, hey, create a really strong password if you want to start reading your email, and similar to LastPass, you can store that password for 12 hours, and we'll re-prompt you in another 12 hours to make sure that you are who you are in this email. Is that kind of how it gets mass adoption then, or?
As far as the question is, how does this get mass adoption, will Gmail require users to use really strong passwords? I don't think that Gmail is going to require users to use really strong passwords.
What I mean is, would that be a solution towards using this sort of technology to get mass adoption?
Gmail suggests you use the authentication.
Yeah, so Gmail has two-factor auth. I mean, you can do a lot of stuff. I mean, there's a lot of creative things that you can do. I'm just describing a system. I'm not saying what is the right way to approach it to gain mass adoption. That's for you guys to figure out. That's for companies like OneName to figure out. That's sort of what they're working on. Is how can we get mass adoption for this stuff? And mass adoption is a good goal to go for because it really kind of it's kind of like immunization for the herd. Why do people get immunization shots? Because it protects not only the people who are immunized, but it also protects the people who are not immunized. And it's very similar effect when you have more people using secure communication. The benefits extend to people who are not using secure communication. Yeah, and a lot of you, I'm sure, are very up to date on all of the the privacy concerns and all that. So, what's up?
Just a question about this expiry thing you mentioned. So, I didn't know about this. So, you're saying that if I put some data on Namecoin and I don't do a transaction from the private key corresponding to that thing, it's going to just get bumped off the market? Is that not working?
Yeah, oh, okay. So the question is, as far as a timeout on Namecoin, if you make a registration and you don't update, you don't send a transaction to update the data that you have stored, will you lose access to that? Yes, you will. Well, I mean, unless you re-register real quick. On Namecoin, the rule is that names expire, and in Blockstore, which is what OneName is using, they actually have like a universe of possible namespaces that can be defined by the namespace creators. So they can actually, I'm not sure how granular the rules can be, but they can set, like, I think the price for what it costs in this namespace to register a name. I think you could make it free. I think you could charge some kind of amount of Bitcoin for it. And they might even allow the expiry to be messed with, etc. Yeah, okay, so let's move on to the solutions. Now, some projects that the OK Turtles Foundation has been working on, which is where I sort of hail from. I started a nonprofit foundation called the OK Turtles Foundation. The name, if you're wondering, I'm just going to leave that a mystery. Yeah. And the OK Turtles Foundation, we've recently updated our sort of tagline. It is now, I think, supporting beneficial decentralization technologies, and we included the word beneficial there very intentionally. The purpose of including a subjective term in our tagline is to encourage people to criticize us. We want to make sure that anything that we're doing, we open ourselves up to criticism. So if you think that something that we're working on is not beneficial for society, you can say, hey, OK Turtles Foundation, what the heck are you doing? You said you were supporting beneficial decentralization technologies. It's not beneficial for reasons X, Y, Z. And then we can be like, oh, yeah, you're right. Sorry about that. We totally, screwed up on that one. But let me describe to you two projects that we're working on. One of them, the first of them, is called DNSChain. And DNSChain is not a blockchain, but it is a server that facilitates communicating with blockchains. Blockchains that are being used for key value data lookups, such as Namecoin, and kind of like hybrids like Blockstore.
You can use multiple chains.
Yeah, it's designed intentionally. A kind of a mission goal or a requirement is for it to be blockchain agnostic. Like, we're very adamant that DNSChain support any chain that anybody wants supported that does these key value lookups. And the reason is because we don't know which chain's the best way for doing this. There's a lot, this is a brand new field. And you guys know from taking these courses that there's a lot of different ideas floating out around there on how to do a blockchain. So we don't want to, it would be foolish of us to say this is the right way to do something.
But are you assuming that there will be one chain or multiple chains? I guess that was my main question.
we know that there will be multiple chains. There are multiple chains that do this. And in the future, we have no idea whether one chain will rule them all or not. We like to encourage not so much competition, but more like collaboration on new innovative ideas. So that's why it's blockchain agnostic. And we're trying to make DNSChain provide a single interface, however, to these different blockchains. So that this is for developer convenience. So that developers don't have to learn the rules of every particular blockchain. They can just use like a single API to talk to different blockchains and perform transactions, read from the database, etc. So DNSChain sits in a box. It's supposed to sit in a box. If you're not using DNSChain like this, you are using it wrong. Sits in a box with a blockchain. I spelled that wrong. Chain. Okay. And it talks to a blockchain node. This can be Namecoin, this can be Bitcoin, this can be Ethereum, this can be any of your favorite blockchain. Next, we currently have support for 3 blockchains. Ethereum support is, we're working with Cayman Nava to add support for Ethereum. We currently support Namecoin. We have support for what was called BitShares DNS and now is called KeyID, and that project is kind of, last I heard, a little bit stalling. I don't know if they're going to pick it back up. And recently somebody added a pull request for Next support, which is a pure proof-of-stake coin.
But I guess just to be clear, you have a singular over there. Even though you're supporting all these, you're only supporting a single chain at a time.
No. You can have as many of these as you want. That's a good question. Yeah. So you can have Namecoin here. Let's just say abbreviate NMC, and you can have BTC running here on a server. These are oftentimes kind of like resource-heavy things to run on a server, especially a VPS that's owned by one person. So usually it's like one. But if you're willing to pay for the resources, you can run multiple chains. And then it's kind of assumed, so far we've kind of like adopted a convention that each chain currently has, at the moment, one TLD associated with it. So Namecoin, if you use a DNSChain server and you ask for okturtles.bit, the DNSChain server will look into the Namecoin blockchain and return the IP address for okturtles.bit. And I don't think that, last I heard, Blockstore has not decided on a TLD. And because they're kind of like a universe of namespaces, there can be multiple TLDs made on top of Blockstore. And Next has .next, .nxt, KeyID had .p2p. So what's really cool about these TLDs? These are not just another TLD. This is not just another .ninja being added to the fray. These TLDs, when you look up a blockchain-based TLD, they are like a new level of TLD. It's like, internal combustion engine versus battery-powered Tesla. These guys can allow you to establish a man-in-the-middle proof connection to that website. Something that traditional TLDs cannot do. Because traditional TLDs use that whole system that I was talking about. And it's even possible, if you're wondering, to migrate traditional TLDs to a blockchain. You can do that automatically. Like you can design a system that automates migrating .coms with their current owners onto a blockchain if somebody wanted to do that. You can migrate some of them, you can migrate all of them. It's possible to, for example, decide that .com will be looked up in this blockchain, and DNSChain will try that first. And if there's no entry for it, then it'll pass it along to the traditional system, which by the way, DNSChain also supports. So it supports both the previous system and blockchain-based systems. And the way that you do that is you have to actually modify the blockchain clients. You have the sysadmin basically put a public key fingerprint into the DNS record, and the blockchain client is going to wait for a transaction that matches, that's signed by the corresponding private key, and you have it ask multiple DNS servers geographically distributed around the world or something like that and verify that yes, indeed, that is the correct public key, and the private, and it's been signed by the right private key, and then it'll approve the transaction and put it into the blockchain, and then you've successfully migrated a domain. Of course, there could be man-in-the-middle attacks, but with enough nodes, you would have to have a global man-in-the-middle attack to prevent this from happening, and it would be noticed instantly.
So since you're distributing this across multiple blockchains, how do you manage that? Because within a single blockchain, it's easier, right?
I think he's got different domains for each of them.
Oh, is it?
So you need
Yeah, different
blockchain
domains
to
for different
manage the
blockchains. Yeah, okay.
Like what DNS curve supposed to do, what you're just describing?
DNS curve,
Putting the fingerprints as TXT records on your DNS server.
I don't remember. I thought that DNS curve was somewhat similar to DNS crypt, but if it does something else beyond that, I know that DNS curve is not designed, was not designed intentionally with blockchains in mind, but there's DNSSec actually does something similar. It has public keys being distributed by DNS, but DNSSec, there's a lot of problems with DNSSec. We have a comparisons page of DNSChain to just about like every other solution that has been proposed to solving these man-in-the-middle problems on the DNSChain GitHub page, which I should probably show you. But before I get to that, let me just move on to Blockchain ID and finish that up. Blockchain ID is another project that we've started, and it's very simple. It's just a JSON format for specifying how public keys for identities, like individual identities, are stored in the blockchain. And it's got this one other feature called, don't remember, probably a good time to bring up the computer. One moment.
Yeah, that's okay. I always do that.
Okay, well, let me just describe. So it's got another feature called either affirmations or something like that. It's very similar in concept to on how LinkedIn, somebody else can vouch for you. They can say, this guy knows programming, this guy knows marketing. Except on Blockchain ID, it's a decentralized way of making those statements. So Mozilla also has a thing called Mozilla Badges, which is to state somebody has these skills, somebody completed a course or something along those lines. So you can make these kinds of statements. Isn't that working?
Is this also with Cayman? I didn't know that was with you. So he's doing attributes with identity, is that right?
Cayman is working on identity stuff on Ethereum, and it can potentially involve blockchain ID. And we plan on sending a pull request to OneName has started a specifications thing called Open Name system, and that includes both software and specifications. So we're going to send, they have a profile specification for identities that allows people to list their Twitter on the blockchain, allows people to list their email, allows people to list their any other information. And we're going to, they've asked us to, or they said sure, basically, when we asked if we should send them a pull request for blockchain ID. So another cool thing that you can do is imagine going, on a website, say the New York Times, to an article, reading an article, and then they have this comment section down below. First of all, with blockchain ID, you can comment in a decentralized way. You can log into any website using blockchain ID. And so you can post a comment to the New York Times, and it's cryptographically signed and verified that, oh, you actually sent it, or somebody with your private key sent it, which is actually really cool, because you can imagine a totalitarian government, somebody who's gone absolutely mad with power or something like that, saying that such and such a person posted such and such a comment to a website when in fact they didn't. Okay, I'm not going to pick on anyone, but somebody made a comment of support for this dictator. Well, how do you know they actually did that? With blockchain ID, you can verify whether somebody actually made a statement along those lines. Thanks. Okay, so let me show you blockchain ID. Everything's not finished. This is the basic idea. It's really simple. It just says blockchain. Make it bigger. Yeah, thank you.
Awesome. Super awesome.
Okay. It just says in the profile there will be a key called blockchain ID. It'll have a version. Here are the keys. Notice there's pub and private. Yes, that actually is the private key. This is an optional use of blockchain ID. You can use blockchain ID to have a user password experience completely decentralized, like just completely decentralized. You can, in other words, have software. You can use a strong strong password to generate a public-private key pair, like Minilock does, and store the private key in the blockchain encrypted with like scrypt plus AES. And then what does that allow you to do? That allows you to effectively go on, like, you don't have to store the private key on your computer, in other words. So you can go on your phone and you can have a password manager that enters your username and password, and it can ask the blockchain, what's my private key for signing a message? Retrieve the encrypted thing, decrypt it with your password, and then sign a message, which is really cool. It results in the same user experience that people are currently used to. For the more paranoid ones, because that would result in these brute forcible keys on the blockchain, for the more paranoid ones, you don't have to specify the private key, you can just store it locally. So in the specification we say that private is optional. We talk about the kind of user experience thing that it does. Endorsements are, that's what it was called, it was endorsements, not affirmations. You can make public statements. So let me give you a neat little usage of this that I've heard from a friend. Imagine you're going to the New York Times and somebody makes a comment. You don't know who that person is. But there's a little badge there that says, oh, this person is from your church. This person is from your meetup group. This person attended Blockchain University. It kind of gives context to people in online conversations. And those statements can be made cryptographically secure using a system like this, which is, I think, kind of nifty. And you can also make such statements privately. So it's also possible to, for example, have a secret group such that when somebody comments on a website, only the group members of that group see that that person is a member of that group. That's another possible application of this. You could also use it, universities could use it to make a statement like, this guy actually got a diploma, and we really signed this diploma. I mean, there's a lot of fraud going on with people inventing diplomas. This can be used to solve that problem. All kinds of other problems. And DNSChain itself, here is the GitHub. I'm currently showing the Mocha branch, which is one of the ones that is far ahead of master. We've got, oh geez, I've got to fix that. Let me see if I can show you what that's supposed to look like. We've got tests. So this thing is actually being tested on Travis to verify that it's functioning correctly. Here's what that table is supposed to look like. And it talks about the advantages of DNSChain. The disadvantage, the main one, is, again, real ownership, that you can actually lose something. Because if you lose a domain, or if somebody else has registered your domain, you can go, hey, I have the trademark for this domain, give us the domain, something along those lines, or, etc. So that's an advantage, and that's why I actually think it's a good idea for these two systems to live alongside each other. You can certainly imagine some websites that would prefer to have their domains in the blockchain rather than on ICANN. Yeah. So then we have a comparisons document, and you can reach that from the README, the alternatives, and also we have a it's in the Mocha branch. Right here, see also how DNSChain compares to other approaches. we have this whole docs folder with how to set up DNSChain, how to use DNSChain, how to set up DNSChain with Power DNS, Namecoin on a server on a Debian machine. When we link to other documentation. But my favorite piece of documentation is the comparisons page. We put, I spent a lot of time studying other systems and going through them. So there's a Google certificate transparency effort. And we explain why it doesn't solve the man-in-the-middle attacks and why it doesn't even detect all of them as it claims that it does. There's DNSSec. DNSSec, yeah, you can read about it. There's convergence. There's also TAC and HPKP. Firefox recently added a feature called HPKP, which is just the concept of pinning a website's fingerprint, SSL fingerprint. That has usability problems because we enumerate them. First of all, it's tofu, which is trust on first use. It doesn't protect users who visited the website for the first time. It breaks websites when their public keys need to legitimately change. In the case of TAC, there's another issue. And then another problem is that all of these systems assume that the client software, this is kind of like a really big one, client software has its current time set properly because they all depend on expiry dates. Like this pin is valid for such and such a time period. Well, what happens if the client's clock is screwed up? Then they're not going to be able to visit the website. They're going to get a warning or an error message. You don't have that problem with the blockchain because all you care about is what is the public key at this current point in time. And DNSChain uses a one pin to rule them all approach. So what you do is, right here, what you do is, a priori, the DNSChain server, completely forgot. Why are we even talking about DNSChain? Why don't you just use a Namecoin node? The reason is because Namecoin nodes cannot be reasonably expected to be run on laptops or mobile devices because they have to be connected to the network 24/7 to have the most recent information, and they use up a whole bunch of resources. So DNSChain establishes a man-in-the-middle proof channel by using pinning. So you know what the fingerprint is supposed to be. You set it, and there are ways of improving that we're working on. As far as in terms of usability. That's the one time that you have to verify a fingerprint. After that, no other secure chat messaging app do you need to verify fingerprints anymore if they're using the blockchain. And yeah, so it's just one little pin and that's it. And then
could you just use like
thin clients?
Thin client.
So that's in our documentation as well. Thin clients. We just recently updated it to add some discussion on thin clients, and we think thin clients are really great. Because they allow you to access blockchain data in an extremely efficient and lightweight manner. And the new approaches are sometimes referred to as SPV+, or Ultimate Blockchain Compression for Unspent Transaction Outputs, UTXO, give you security that's, if not equivalent, nearly equivalent to a full node. But there are still problems with thin clients. First one is their non-existence. There's no thin client out there that does SPV for these arbitrary key value data stores. And there's not going to be one for some time because they're very difficult to implement. Over-reliance on SPV clients can lead to a centralization of the entire network because there are fewer full nodes running out there. So DNSChain actually incentivizes people to run full nodes, which is good. It keeps the network decentralized and healthy. If all the SPV clients are just talking to a couple of full nodes, and that actually might be more of a realistic possibility than you might think when we get in terms of high transaction volume and the scalability problems that you guys might have covered in this class. That means that fewer people will be able to run full nodes. Some platforms don't support thin clients very well, like iOS. On iOS, you cannot have a server running in the background that other software talks to. That's not approved. That's not an Apple server that Apple has specifically allowed. That's for battery life reasons and things of that sort. So in that case, you would need a thin client with every single application that wants these features, that wants this security. And supposing you did that anyway, you still have the problem from a user experience where mobile devices are offline frequently, and they get out of sync with the network. So the users will have to wait, that means, for the thin client to synchronize back up, pull the latest headers from the blockchain. And then every single request to a new website has to do all of this extra overhead work of looking at the Merkle tree, pulling the correct transactions and all of that stuff. So that makes connection, that adds latency to every connection. There's latency when you have to synchronize back up with the network. In other words, you won't be able to visit a website for like probably several seconds, depending on how long you've been offline and how long it takes to retrieve all of the transactions and verify that they're correct. With DNSChain, with like a framework, an app that uses a framework that lets it talk to DNSChain via an API, it's instant. You just say, what's the fingerprint? And over that connection, you don't need to wait. You just instantly get the fingerprint, the correct one. Okay, so one more thing. We're about to release a major update to DNSChain. It's going to include a lot of new features. It's going to include, let me see here if I have one. Yeah, this is the feature list for DNSChain 0.5 coming out apparently a few days ago. Is that? Okay. So we're actually we added support for retrieving ICANN information, traditional DNS over HTTP or HTTPS via a RESTful interface. We added the next support for the next blockchain. Maybe we'll get, depending on what the one-name guys, maybe we'll even add support for the block store, either this release or the next one. We added traffic throttling to protect from DNS amplification attacks and to protect your server from people who are abusing the RESTful API. We added Redis caching for both DNS requests and HTTP RESTful requests. We added full HTTPS support. We're working on also censorship circumvention through unblock, where you use the DNSChain server as a proxy. And that's a whole other conversation. So we did a lot on very little funds. By the way, you guys should donate, help us out, or just help us with the code. That would be also awesome. Add your name to this list of contributors, and as far as a RESTful API goes. Let me show you what API is coming. We've got this thing coming soon. This is really cool. So there are a lot of companies whose sole business model is offering a RESTful API to the blockchain. While that's great, we're not super thrilled with that because that's like, a step backwards in our opinion. The blockchain is about decentralization. When you add a company that's offering a centralized, easy-to-use point for resolving information on the blockchain, you oftentimes, depending on how they implement it, have to completely trust what they say. And that's having a central point of failure as well, another central point of hacking. We don't like that approach. We want people to, if they want, run their own DNSChain server or trust of friends, or when thin clients come out, use DNSChain as kind of a middleware to thin clients so that locally they can use this API, this one RESTful API, to build applications, secure that email that behaves just like regular email, but is fully end-to-end encrypted and doesn't rely on untrusted third parties. iMessages, etc. All of these different secure messaging applications. You can start building applications that just use a very simple RESTful API. You can see that it has, the version number, the blockchain, the resource, the property that you're looking up. So this is ID/Bob, URL encoded. So yeah, resource, property, operation. So like here, we have an example of an operation, transfer, optional arguments, what address we're about to transfer something. Initially, we're only going to have support for reading from blockchains. In the future, we'd like to add support for writing to blockchains as well. And you can do that in a way that doesn't trust the DNSChain server by holding the private keys locally and just signing messages and sending them to the DNSChain server to then send to the blockchain to distribute to the rest of the network. I think that it's 12:23 right now. I think this is a good stopping point, and now I welcome your questions. Yeah?
There's one disadvantage of doing stuff on the blockchain, which is like you can lose stuff that you mentioned. You mentioned that one disadvantage, right, relative to other schemes.
Can you speak up a little bit?
You said there was one disadvantage with storing stuff on the blockchain was that you could lose stuff, right? When you were comparing
Oh, right, yeah, I forgot to mention that. Let's go back to blockchain ID. So notice these, so there are two keys, in other words, two key pairs. There's one key pair that you're using on a daily basis to sign messages and to verify other people's messages. These keys are stored in the blockchain. And then there's another key pair, you can think of it almost as a backup or emergency key pair, for actually updating the information that's in the blockchain. So say you lose the public-private key pair, or it gets hacked or something. This one, these two, or this one and the one that's like stored locally. You can simply then use the other key pair for updating the entry in the blockchain, and just switch these out, update them to something else, generate a new one. Yeah.
But I guess what you were referring to is that the other one that you code as a backup, that's signing.
Yeah, that one can be lost, and then you're like, then you need to rely on some of those other methods that we talked about, like multi-sig, shared secret sharing.
Right. Yeah, so I was actually going to ask about the secret sharing. Is there a secret sharing based scheme that has tried to address this problem? Because the thing with DNS as it is today is it tells you who you need to trust. With secret sharing, you can decide who you are going to trust, right? And so I think that even though there's some transfer of trust involved, that's a better.
Yeah, so the comment is that with DNS today, it tells you who you need to trust, or with X509, it tells you who you need to trust. Whereas with secret sharing schemes, you get to decide who you want to trust, with your identity, with your bitcoins, etc. And yeah, we think that's a better world.
So all these things, they seem to imply control of the namespace, where there's no central authority that controls that namespace. But for things like, for the real world where you might have, trademark law or other socially mediated kind of mechanisms for talking about how we name things, are there mechanisms, like, it seems like all of these things are based on the first come, first serve. Like if you take a name and you have the private key for that, then that's what prevents anybody else from coming in and taking that name. But it doesn't represent any sort of social process that name is recognized by anybody else. So I don't know if you guys have put any thought into that.
Okay, so let me see if I understand what you're saying correctly. Basically that a lot of these blockchains are first come, first serve as far as name registration is concerned. And the concern, can you be more clear?
And that there's no social process for overriding that.
And there's no social process for overriding that, right?
Yeah, and so I'm just wondering if there's been any thought put into, can you have...
Yeah, that's a good question. Actually, I think, well, first of all, okay, as far as first come, first serve goes, there has been thought to addressing that. People have implemented, like BitShares DNS had a bidding system for registering names, where there was a period of time where you could bid on names. Blockstore, my understanding is that the rules for each namespace define what's required. Like they can even specify the price of particular names. I think they were looking into that. I don't know if they actually implemented it, but like based on the name length, for example, the shorter ones come at a higher price, etc. The person who owns the namespace can specify what the rules of that namespace are. That reminds me, earlier on I was talking about malware, or there was a conversation about malware. You can protect against malware by storing the hash of binaries in the blockchain, and when you download the binaries, verify over a man-in-the-middle proof connection the hash of that binary. That's another huge potential opportunity for a use case for blockchains to verify updates of software and make sure that they haven't been tampered with. And actually, but to finish answering your question, as far as a social mechanism for restoring names to their rightful owners, I don't think enough thought has been put into this, and that's something that people should be thinking about more. You can imagine, of course, like there could be a legal system. If you know who registered a domain name, you can compel somebody to hand over their private keys through the legal system.
or sufficiently distributed multi-sig type thing where...
Right, and you can imagine coming up with a way where, like, your ownership depends on several other people agreeing that you own a thing. You can imagine people establishing organizations to sort of reinvent ICANN on top of the blockchain, where ICANN has part of the private key or has the private key, and everybody trusts them to be honest. So you can reinvent the current system on top of the blockchain, but you can also not. Yeah, you can do both. I think you had a question.
Yeah, my question was similar. All of these blockchain distributed, whatever, name registration systems have one thing in common. How do you stop the first guy from grabbing every desirable name, A through Z, 2A through 2Z?
Right, well that's usually financial.
A through triple Z, and so on.
Yeah, so how do you stop people from name squatting? It's a very important question, and the way that people address it is by putting a cost, just like in traditional squatting problems. People squat on traditional domains all the time, and there's a cost to registering each one of those domains. What's nifty about Blockstore is that they allow individuals to register a namespace and then allow the individual to decide what the rules for that namespace will be. So I think that's really cool, and I think that can go a long way to addressing that problem, because you can have some highly desirable namespaces that, for like businesses, where the cost of registration is high. Somebody really wants this domain, they will pay a good amount of Bitcoin or whatever the currency is for it. And then you can implement bidding systems on top of it, where the initial registration goes through a bidding war for a certain period of time. A lot of innovation can be done there, and these are all awesome projects that you guys can work on. Yes?
Yeah, the hard part is if you require bidding for every name, then it's slow, and it also leads to leaving names high and dry. A really complete solution, you'd have to kind of have an auction for each name, not just that, but it would expire, and there'd have to be a market for each name, because if you require bidding and a high price for everybody, you're going to massively overvalue all the names, but massively undervalue a few desirable names at the time.
Right.
So it's not an easy problem to solve.
Yeah, it's not an easy problem, and there are multiple approaches to solving it, and it might turn out to be kind of an evolutionary thing where we will find out after the fact what the best approach is by seeing how these different namespaces, how popular they are, and what people's reactions to them are. Are they able to get the name that they want? Are they unhappy about squatters, etc.?
The cool thing is you'll have the statistics on how it evolved, which we don't have with the current namespace, like how they got consumed and changed in value.
Right, yeah, so the comment was that it's neat with the blockchain that all of this is kind of public information, and so we can, after the fact, analyze the data and see which namespaces blew up, which namespaces, et cetera. We can figure out what a good approach to solving name squatting is.
So I think you have to ask my question. So for doing the secret sharing to mitigate this one disadvantage, is there any support needed in the blockchain or DNSChain, or it's just a user's implementation choice?
For doing so, the question is for doing secret sharing, is there any support in the blockchain or in DNSChain for doing secret sharing? No, there isn't. I don't think there's any support in the blockchain for doing it. But then again, with Ethereum, you can never be sure. And there isn't anything with DNSChain. That would be like client-side end-user software would be responsible for recombining keys and things of that sort. And there are libraries for doing that stuff.
I think I read it real quick. I can't find it now, but are you using cryptography or that kind of a technique? Put this information in? Or are you putting it in the operator code, the actual coding of this information? Is this what you're talking about?
I'm not quite following your question.
I read through this real quickly. I thought it said cryptography, and I was just wondering.
No, we're not using cryptography. Okay.
You talked about Mozilla a few times. What's Mozilla doing with the blockchain? You guys.
What's Mozilla doing? That's a great question. You should ask them. They are. I have like reached out to them a couple of times, and the feeling is that I'm getting from them is a kind of a hesitancy, and you can imagine why they might be a little hesitant. I think it's up to us to make things a little easier on them because there's a whole lot of financial stuff at stake here. You know, they talk to certificate authorities all the time. There's a whole bunch of money at stake for certificate authorities. So there's probably a lot of pressure on Mozilla to not, you know, shake things up a little bit too much. But you can, I think, gradually ease your way in. We're going to be crowdfunding for, actually, our next step is to work on OpenSSL and give OpenSSL blockchain powers. And when you do that, you kind of leave them with no excuse. Any other questions?
I guess just a little bit of a comment. I was just thinking about like if somebody, you know, for good or bad, Ethereum seems to have a lot of stuff that they pull in house, like they have. So I'm just wondering, what if somebody with some blockchain does it in-house? I guess one problem that you listed was that you thought that SPVs would be a problem, but I mean, I guess I'm just thinking out loud about what the advantages would be to be having a system that works with multiple blockchains. I guess it's a little bit more robust.
Well, a system that works with multiple blockchains, if you use it, you encourage blockchain innovation in this area. You encourage blockchains to, in some sense, compete with each other to see who can come up with the best system for doing this. And that's one reason. And a second reason is it makes life easier on developers because we are working on a specification so that, you know, anybody can come up with a version of DNSChain or implement this spec into a blockchain, like directly into a blockchain. So they don't have to use DNSChain at all. And here's the spec that we're working on. It's currently a draft. And it talks about, it's very short and brief, but the basic idea is entirely in the HTTPS RESTful API part. And then there's also potentially a DNS section to it where you can have like a simplified version of DNSSEC that simply sends signed DNS records back from DNSChain. You can do that as well.
Okay, yeah, thank you.
Mm-hmm. Any other questions? Okay, I think that's it. Thank you guys so much for having me.
Greg Slepak, OK Tables Foundation, and we'll take a break for lunch, come back and work on projects.